Alright, so this video is going to be about sine functions, but it's my fourth video, and if you haven't checked out the first three, you should, because those covered amplitudes, reflections, and what happens when the period changes, and this one's going to incorporate all those things, but the last thing is also going to be a phase shift. Now, a phase shift is the same as a horizontal shift, and so we're going to talk about what do you do when shifting the graph left and right. But your main goal is to really figure out when there's a phase shift or a period change for that matter. The main goal really is to figure out where the graph starts for a period and ends. And so hopefully by the end of this video and your lessons in class, those type of things, you want to know where the graph starts and ends. If you can figure out where the graph will start and end, you'll be in really good shape. If you can't do that, then definitely ask for help, post a comment or something like that, and maybe I can give you some advice. But that's the main goal when you're talking about a horizontal shift in a sine function. So let's just go ahead and take a look, right? So remember, just quick review, this is what a sine function looks like. You have your x values, right? We plot 5 points for a sine function. You're at 0, 0 is where you start, and then let's say this is 1, right? You go up the amplitude, then down, down, and then back up. And so there's one period, right? That's one period from 0 to 2 pi. That's one period of a sine function. So this is 0, this is pi, this is 2 pi, this is going to be pi halves, and 3 pi halves, okay? And so that's one period. So what we're going to be doing, obviously, is we're going to be shifting that left and right. And so just a couple things about that shifting. Remember, this would be a shift to the left. A shift to the left would look like this: y equals sine of, and then parentheses, x plus pi. Remember, when it's on the inside of the function, it's going to be kind of the reverse or opposite of what you see. It looks like it would be positive pi, and so you move it right pi, but in essence, it would be a shift left pi, and so this graph, left pi, instead of starting at 0, it would start, right? It would start at negative pi on the x-axis, and then if we add the period, which is 2 pi, it would end at pi. So if we're taking a look at the graph over here, just kind of give you a visual of that, this would be negative pi, and so the graph would start here, go up, down, down, up, and so now we have a shift to the left pi, right? So a shift right, a shift right would look like this. It would be y equals sine of x minus pi. And so even though it looks like it's negative, it's not. It would shift to the right pi. And so now you would start at positive pi, right? That's where the graph would start. And then you add the period, and it would end at 3 pi, because we add the period, so pi plus 2 pi is 3 pi. And if you're looking at the graph again, that would be 5 pi halves, this would be 3 pi. And so the graph would start at pi, and then go up, down, down, and then back up again. And so there you have the new sine curve shifted to the right pi. And so our goal here is to make sure that we can understand how to, right, start and end this, but also to incorporate all the other things that we've done, the amplitude changes, the period changes, and the vertical shifts. And so we'll try to add all that in by the end. But that's really all we're doing, is shifting things left and right. So one more time as a quick review, this is the graphing form that I gave in all my videos. And so if we're taking a look at kind of what it all means, once again, this first one is your vertical shift, right? D is your vertical shift. A talks to you about your amplitude, or your vertical stretch or shrink, your amplitude, and it also talks to you about your reflections over the x-axis. And then B, we talked about, is the period change. And the period change is going to be done by doing 2 pi over B. And then the last one, obviously, is what we're talking about here, is the phase shift. And that's your horizontal shift or your phase shift. And remember, it's the opposite of what you see. Okay, and the last thing I'll say about this is take a look here and notice that this, I've tried to write it this way. I don't know if textbooks really write it this way, but I've tried to write the inside in factored format. Because if you take a look at this first example that I've got here, you can't see, right? You can't see the horizontal shift until there is a coefficient of 1 in front of the x. And so if you take a look at this first example, notice that there's a 1/2 in front of the x. Well, we need to actually factor out the 1/2 before I can see the horizontal shift. So saying for this first example, the horizontal shift or the phase shift is not right pi halves. Okay, so we're going to break it down as we've done in all my videos. So we want the amplitude, we want the period. If there is a vertical shift, we'll state it. Then a phase shift. Okay, maybe there's domain and not maybe there is domain and range, but we'll worry about those later if we need to. Okay, so first thing that you want to do is you actually want to factor this. Now you can't factor it out of the sine, but you can just say this would be the sine of parentheses 1/2 parentheses and then x minus pi. So if you take a 1/2 out of everything, it would just be x minus pi. If you want to check your work, distribute the 1/2 back in, and it should be the original. Okay, and their 2 is still there. So then nothing changes there. All right, so our amplitude is 2. Now to figure out our period, we're going to do 2 pi divided by 1/2, and that's going to equal 4 pi. Our vertical shift, there is none. And our phase shift, now we can really see it now that it's factored, is it's shifted right pi. Okay? And so the next thing you want to do is you want to figure out where your graph's going to start and end. Okay, so what I do is off to the side, as I did above, I write start, and then I kind of make my little axis here, and then I can write end here. Alright, so think about this. Normally the graph would start at 0 because it's a sine function. It would start at 0, but it's shifted right pi, so the start of my period would actually just be at the value of pi. So whatever the phase shift is, that's going to be your start. Okay? Then to figure out the end, all we're going to do is add the period, right? So from that, we're going to add the period plus the period. And so the period is 4 pi. So pi plus 4 pi is, you guessed it correct. I know I heard you say 5 pi. That's good. Thank you. All right. And as I said in my other videos, to figure out what the spacing is of the notches, since they have to be equidistant, we can take the period and multiply by 1/4. And so 4 pi divided by 1, or divided by 4, or multiplied by 1/4 is just pi. So they really just go by pi. So this is going to be 2 pi, 3 pi, 4 pi. And that's pretty easy. If you want to figure out where the second function or second period of the function would be, you can go this direction. So you know it would be at 0, negative pi, negative 2 pi, and then negative 3 pi. Okay, and so there's your x-axis that you're going to have to kind of find and space out. So I'm just going to go right here and say that this is pi, 2 pi, 3 pi, 4 pi, 5 pi, and then there's 0, negative pi, negative 2 pi, negative 3 pi. Okay, I'm going to write these down here, negative 3 pi. And next thing we know it, we're ready to graph. So the middle is still at 0, y equals 0, and sine starts right in the middle. So I'm going to go to my starting value, which is pi, and I'm going to plot my initial point at 0, and then I'm going to go up the amplitude. So I guess we could space these by 2 as well if we want. And then go up the amplitude, so that would be here, down the amplitude, down. There it is. So there's one curve going from pi to 5 pi. Okay, you can do another one. Just keep the pattern going. Oops. Okay, and there it is. You could do the domain, the range. Domain's all real numbers. The range is from -2 to 2. Seems good. All right, so let's just try one more, and we'll call it good. It's got everything in it from all 4 videos, so hopefully you can do it. If you want, give it a shot. Try it on your own. Hit pause, and then you can watch the result after. So feel free to do that now, and then hit play once you're done. All right, but best way to do it would be to break it down. We've got the amplitude. We want to know the period. We want to know the vertical shift. We want to know the phase shift. And what the heck, we'll throw in domain and range as well. All right, so amplitude is 1/2, but we know that we need to do a reflection. The period is going to be 2 pi divided by 2, so that's going to equal pi. Then we need to factor this on the inside, so that'd be 2, and then x minus pi halves. So my vertical shift is up 2. That comes from this guy right there. My phase shift is right pi halves. Okay, and then my domain I know is all real numbers, and we can look at the range once we're done if you don't want to think about it too much in your head. But let's get going. So I'm going to figure out where it starts. So it starts at, let's see, 1/2. Nope. It's going to start at pi halves. Right? Positive pi halves because it went to the right pi halves. And then where's it going to end? I'm going to add pi, so it's going to end at 3 pi halves. And then to figure out what the notches are going by, I take my period, this guy right here, and multiply by 1/4. So that's pi over 4. And so you kind of want to think of things in terms of over 4. So pi halves is really 2 pi fourths. And we're going to count by fourths, so that'd be 3/4. 4/4 is just 1. 5/4, that doesn't reduce. And then 3/2 is the same as 6/4. And so there's our x-axis. If we want to go the other direction, right, we would need to count by fourths. So once again, pi halves is 2/4. So that would be pi fourths. 0, negative pi fourths, and negative pi halves. And so there's our 2 periods that we can go with, and we know where both periods also end. All right. So our vertical shift is up 2, so I'll just keep it kind of going by 2's. 1, 2, 3. Especially since our amplitude is 1/2. All right. Go with just by ones, I know. All right. So you kind of see how I've got it labeled. I've got this as pi fourths, pi halves, 3/4, pi, 5 pi fourths. Guess I need one more. And then 3 pi halves. 0, negative pi fourths, and negative pi halves. Alright. So, vertical shift up 2, drawing in my dotted midline. Whoa. There it is. And then we're going to start graphing. We know we need to reflect it. So sine is the graph. I'm going to start at the midline, but then I'm going to go down the amplitude. So half, up, up, down, follow the pattern. And there we have it. Okay. And that would be my graph. Your range would go from 1.5, I believe, lowest value, so 1.5 to 2.5. And hopefully that makes sense. Let me know if you liked it. Have a great day. Keep it real.